follow along. And I'll try to be explaining everything very clearly so that the entire video would be understandable. So getting started with the code in this course is basically our objective. And during the course, we will basically covering the following topics. So how to download the course codes from GitHub. As you know, the textbook, the recommended textbook for this course is Machine Learning with PyTorch and Scikit-learn. You are not required to have this. I recommended that you could get a physical version or a PDF copy, but you really don't have to have it unless you wanted to have it. I like the book, so I bought it. So, but the good thing is what you need to have is the codes that is basically taught in the course. And all the codes of the book is actually available publicly online on GitHub. And we will show you today how you would be able to download this from GitHub. And later on, we will cover briefly how to install Miniconda and Anaconda on a local machine. This is not a preferred way for you to do this if you don't have previous experience with setting up your own machine and doing data science project. I still cover it. I do not recommend it for beginners. So it's not hard. I recommend no matter what skill level you have, you go through this and practice it, but I do not provide you guarantee that you would be successful on that. But there's a forum, which is called Environment, which if you're really interested on setting up your own environment, which is not necessary nowadays, you would be able to kind of like the errors and stuff that you would get, you can discuss. Again, I don't guarantee that I would come and then read all the blogs in the forum. I would love to. I love setting up machines and doing administrations, but just my time is limited and I don't have a teaching assistant to help me with that. But I still take a look at the forum, and it is something quick. I would help you if you're interested to learn this. And after that, we basically sort of show you, how to create a Python environment and install your packages. And then we actually move to an important thing that you should learn today. And I would recommend you to kind of practice it. And that's like how to launch and use a Google Colab and a Kaggle notebook to run the codes that you have downloaded earlier. So this part you should know. So the second part is kind of optional, although I highly recommend, especially if you are studying computer science or machine learning as a major. I mean, you should learn this. So it just doesn't make sense if you don't know it. So, I mean, no matter what, make sure you get a hang of like using Google Colab and Kaggle Notebook. That's basically set up environment on the cloud, which is very easy to use. And they have other benefits as well that even if you chose to go on the second route, the first route of installing Miniconda, you should still learn how to use Google Colab. And there are reasons for that, which we will cover, and also Kaggle. And I highly recommend it. Again, this is my recommendation at the time of recording this lecture, which is February of 2023. This area is fast changing, and my recommendation might change 6 months later, but that's what I recommend right now. So you need to know about these resources in the community and be able to use it. And then finally, we will basically conclude with a summary of what's being covered. Okay, so the way we're going to do this is this lecture, a lot of things is hands-on, and I'm doing this type of presentation for the first time online to kind of switch between the presentation deck and basically my screen. So I asked one of the students to volunteer to help me make sure sort of the switching of the screen kind of makes sense, because I thought it's nice to have a presentation so that you understand what we're going to do. And then I actually do it once so that you can later either follow along, or even if you like, you can follow along right now. If you're following along right now, we do not discuss the problems at the session. You could later on, after the session, go ahead and then use the basically the discussion forum to kind of post your errors that you're facing right now or later on when you're watching, and we can discuss that. And most probably your fellow student classmates, they can actually kind of discuss that with you, and I would help as much as the time permits. So I think the first important thing is like let's sort of go over the first step in getting started with coding, and that's downloading the code repository. So the code for the textbook, Machine Learning with Python and Scikit-learn by Sebastian Raka, is available on GitHub. So as you probably are already familiar with GitHub, but if you're not, it's a popular platform for sharing and sort of collaborating on code projects. So to access the code, you'll first need to visit the repository link, which is provided on the slide. And that's github.com/rasbt/machine-learning-book. Once you are on the repository page, you can download the entire code base by clicking on the green code button and then selecting download zip. This will download a zip file for the repository to your local machine. So alternatively, if you are a command line fan, which I am assuming a lot of you should be, then you can actually use the, and you're familiar with the command git and you have already installed it on your system, you can simply clone the repository by using the command git clone, and then the same URL that's provided in the slide, https github.com/rasbt machine learning book in your terminal. So once you've downloaded the repository, so if you have used especially the manual approach of clicking and downloading of it as a zip, then you have basically all the code you needed, and to follow along the course. I mean, if you also use the git command, you still have all the codes. The first approach requires you to unzip it as well, and then yeah, so you have to unzip it if you have basically used the manual approach. And but let me just start to kind of switch the screen and stop sharing the slide here, and now let's do this together. All right, so I need Daniel's assistant to ensure that we are having a Google Chrome page up right now on the screen.
Yep.
Okay, sounds good. So this is the repository. So I've already typed it in, and you enter, and then of course you get into the repository. So this is the repository of your book, which has basically all the chapters, and the codes are on each of the chapters provided in each of the folders as a IPython notebook. So this is the green button code that was explained earlier, and then you can press it and you can use download zip. And then once the code is downloaded, you would get it on your folder. Once you downloaded the code, you would have this folder, and you should unzip it. I'm using MacBook here, so and similar instruction should be able to be performed in Ubuntu Linux. I don't use Windows I can't kind of like provide you instruction on that, but I'm under the assumption the very similar instruction should be done there as well, but I haven't done those. So this is the book that's kind of now downloaded. Okay, so let's do the same thing over the terminal. I would ask Daniel to confirm that basically you'd see a Linux terminal right now.
Yep.
Daniel, perfect. All right, so let me clear the terminal. Okay, so once you open the terminal, you should have a terminal like this on your machines. Same instruction would happen on Ubuntu as well. In fact, I do have now parallel to this machine on Ubuntu, and I have all the same thing there. If you're using Windows, I know that you should use command prompt, and you should be able to do the similar things, but I haven't tested that. All right, so you can go to sort of your desired folder. I have already downloaded this, so I'll make just a test folder. Okay, so here's the test folder, and if you wanted to use Git, you just need this. You'd need this URL, and then same download action that we've done manually. You can do it via Git command. If you're not familiar with this, don't worry about it. So this is basically downloading the repo here. So I'll let this getting downloaded. So far, what we've done, we just discussed the codes of the book is publicly available online. We show you two approach to download it, either manually or basically leveraging Git commands. So nothing special. I found this picture cool, so I just use it instead of sort of regular Python logo. So let's see what we want to discuss here. So we're going to discuss here about Miniconda and Anaconda and why we are using them. So Miniconda and Anaconda are both open source distribution of Python and R programming languages. Miniconda is a minimal distribution that contains Python and conda, which is an open source package management system and environment management system. On the other hand, Anaconda is a distribution that contains conda as well as over 1,500 other packages, including Python, R, and other packages. So if you wanted to basically set up your own environment at your local machine, which, as I mentioned earlier, this is not, it's just an optional action. I do that. I also use cloud, but for you should figure out what is the best workflow. I like to always have access to one version of my machine learning system at the local machine that I use, and also sort of for any kind of heavy work, I would use the cloud. But for this course, you don't have to basically go through this Miniconda installations and things like that, because it needs a little bit of hands-on system sort of management. And if you don't have that, things can get very confusing, right? So, but we still cover this because the class, consists of people with different backgrounds. So I thought these materials are important for some of you. And for those that are interested, I recommend you to, after the class, do this. And a lot of you might already have Anaconda or Miniconda installed on your machines. So that's basically the first part. So I'm not going to download Miniconda or Anaconda right now as part of the demonstration. That takes some time, and I don't want to mess up my machine because I have a nice clean install. But feel free to go, and depending on basically of your choice of OS, go to the docs.conda.io/en latest miniconda.html. Go over the instruction that's provided for your system and install miniconda. I recommend miniconda. Well, a lot of people, they recommend Anaconda for beginners because basically they say it is easier to work with, but I actually really like miniconda, and I think it's less bloated and it doesn't have unnecessary packages. I like to know what I'm working with. I don't want a bloated system that has so many things in it that when an error pops out, I don't know why the error is there. So yeah, so as I mentioned, visit Miniconda Anaconda website and select the appropriate version for your operating system, and be sure to select the version that corresponds with the version of Python that you're using in your system. Once you have downloaded the installation package, simply follow the prompts to complete the installation process. It's worth noting that both Miniconda and Anaconda support a variety of operating systems, including Windows, Mac OS, and Linux, as I discussed earlier. And you can basically also choose between Python 2 and Python 3. I usually use Python 3, so most of the people I know, but it has all those capabilities. So and that's it for this slide. So in the next slide, we'll be going to cover how we can sort of activate and how to activate and deactivate a virtual environment using conda. Okay. I understand this is a very wordy slide, so don't worry about it. This is mostly for your reference and some notes that you can later on refer to, but we're going to demo this and you will see every section of this. So as I did earlier, I will explain about this first, and then we switch the screen and we would actually do it so that you get a hands-on. Feel free to go along or do this at your own pace later on if you're experimenting with Miniconda and Anaconda. So we'll go through a step-by-step instruction for creating a new environment with Miniconda or Anaconda. In my case, I'm actually using Miniconda, but same instructions apply to Anaconda. We also cover some information about activation and deactivation of the environment. And with that being said, let me explain to you what is the Python environment, right? A Python environment is a way of isolating different versions of Python package and dependencies. This is useful because different projects may require different versions of the packages and dependencies. And creating a separate environment for each project that's basically you're working on, that ensures that the correct version of all the dependencies are being used. Again, it is worth noting that a lot of this instruction might not be useful if you are using the preferred way of doing the homeworks and assignment in this course, which comes at the very end of this lecture, and it's using cloud services like Google Colab and basically Kaggle, and all those things are taken care for you, so you don't have to worry about it. So if some of this thing is overwhelming for you, just relax and just hear and try to kind of just understand such techniques exist and they can actually do this. It could be overwhelming at the first time if you haven't heard about all these packages. But if you have heard it and you use it a few times, you can get an understanding of what's going on. Okay, so
I have a quick question.
Go ahead.
When we're setting up our Kaggle and Colab, do you care if I use a personal one that I've done stuff in before? Do you want a fresh, clean one for the university or anything while we're getting those environments set up?
Yeah, Daniel, thanks for the question. It's up to you. You can use basically a fresh one. You can use the one that you already use. I'm using the one that I already have. I don't see any reason why you would want to sort of create a new one, but maybe maybe for some reason someone wants to have different account. That's fine. But yeah, it doesn't matter because every time you create a new notebook, it's a new notebook in Kaggle. So even if you have an existing account, you can just create some new notebooks as new projects in your existing account, if that makes sense.
Yes, thank you.
And thanks for the question, Daniel. So to create a new environment with Miniconda or Anaconda, sorry, I just want to make sure that I'm not on mute. To create a new environment with Miniconda or Anaconda, you can use the following command. And that's conda create -- name, and then use the name of your environment. So in this example, I have called it my environment, my env. And then to activate an environment, you can use the command conda activate the name of your environment. And to deactivate it, you can also sort of use conda deactivate. And with that being said, sort of let's start kind of practicing with that, and we're going to switch to the demo so that you would learn how to do this. And again, by creating an environment and managing the packages and dependencies within it, you can ensure that your projects run smoothly and without conflicts. So if on your local machine, you have multiple projects, each project has different dependencies, different version of Python, different version of like NumPy, pandas, scikit-learn, keras, and you name it, matplotlib, you would make sure that that specific environment belongs to one project, and that would work. In our specific case, you should treat our course as one project for basically when you're practicing the codes in the course or you're doing your homework. So, and when I'm referring to project in the next demo, I'm talking about this basically being able to execute the codes of the course, and that's going to provide it to you from the GitHub, right? Which also is a prerequisite for you to be able to do your homeworks. So let's switch the screen. Okay, so you should be able now to see basically Linux screen. All right, so by the way, notice that the previous command that we executed was git clone in the previous demo to download the entire machine learning book library from basically the GitHub, and that has been done. So I'll also quickly check this to make sure that that previous task, and you see that the book is actually downloaded. And so that's from the previous task that we have done. Okay, so now let's create basically a new environment. Okay, so why not we actually sort of create an environment very similar to what's been discussed in page 17 of the book. So if you have the book, there's a page 17 of the book that's kind of talking about creation of this environment, and they're creating an environment called PyML with the Python 3.9 version. So I will replicate that here. So when I do execute this command, it's going to ask me that if I would be okay with having this packages within this specific environment that I'm creating for the course. I'll press yes, and it's going to install them. So notice that in the command, there was a portion that was basically there was a portion that was basically sort of talking about the version of the Python. So, and I was asking it to be 3.9. And then based on different projects in future and that you would be working, not necessarily for this course, of course, you can create an environment with different version of things. All right. So next thing we just learned was how to activate the environment, because that environment is not activated now. So I'm in a default base environment, not that a specific environment that we just created. For that, we just use the conda activate and then the name of the environment. And then now we are at the, if you can notice right now, the precursor to my basically Unix information here changed from base to PyML. So right now I'm in this basically a specific environment, a Python environment that I'm created, that all the dependencies, everything is going to manage within this virtual mini conda environment. And what I can install anything, I can add any packages, and I don't have to be worried that my entire machine sort of be affected. All right, so with that being said, let's get back to the slide. All right, Daniel, you should be able to see the same slide that we were at.
Yes, I can.
Sounds good. All right, so let's now talk about installing packages in an environment. We'll cover how to install packages in an environment that we just created in the previous demo on the slide. First, it's important to understand that there are 3 package managers that can be used when working with mini conda or anaconda. Sorry, 2 package managers. And that's conda and pip. So conda is the package manager that comes with mini conda and anaconda. It is a cross-platform package manager that can install packages for multiple languages, and that's including Python. Conda can be used to install packages from the Anaconda distribution or from other channels. Now, pip, on the other hand, is a package manager for Python packages only. It's commonly used to install packages from the Python package index, which is also called PyPy. You might have heard PyPy, and that's basically the Python package index, where you can use pip and then it connects to internet and download the packages, right? So to install the packages in an environment, we need to activate the environment first. In our case, we just did this in the previous demo. Once the environment is activated, we can use the command conda install or pip install to install packages. So, for example, let's say you want to install packages like NumPy or any of the other packages. And let's say NumPy as an example. And in that case, if you want to use conda, you would basically run the command conda install NumPy. To install the packages sort of using pip, as an example, you can think about pandas. So let's say if you want to install pandas, the second library on the slide, using the package manager pip, you would use pip install pandas on the command line. It is sort of worth noting that when installing packages, it's a good practice to specify the exact version of the packages that you want to install. And as I previously mentioned, this is basically to ensure that your code will run on other machines with the same versions of the packages. So some common packages that use in machine learning and data science projects that include NumPy, pandas, matplotlib, scikit-learn, PyTorch, TensorFlow, Keras, and to just name a few. So with that being said, why not we actually try to install one of the packages as an exercise in our demo? So let me switch the screen. So I would refer you now to page 16 of the book, and I would basically pretend that I'm reading this, and I'm also creating my environment PyML. And I would see that in the page 16, it says that they are using NumPy version 1.21.2. So let's see if we can actually, we have already activated the environment. As you see in the previous command, we activated the PyML. We are in the PyML, and the way to know that we are in that environment is the highlighted version shows which environment we are at, and I'm already in PyML, so that's good, because that's very important where you install things. When you install things, it's going to be installed in the environment that you're at. So let's follow along, and then let's try to kind of install the NumPy package 1.21.2, which was discussed in page 16 of the textbook. So I would use conda install. Then I would use the name of the package, which is NumPy. And then I would specify the version, which is 1.21.2. Let's see if that actually works. Seems it works. It actually connects to the repository and asking me that it wants to kind of install the following packages. I would press yes. And we're done. So now the NumPy is installed. I explained about all these things. I usually explain the hard way for the things very comprehensively, and sometimes the hard way to make sure those that they wanted to know everything thoroughly, they know it. But then I also sometimes like to find shortcuts, but I do explain the shortcuts usually toward the end of the lectures, because I want you to not get confused and not having any kind of understanding of what's going on under the hood. So another quick way to set up environment is basically by using the provided environment YAML file. So every person that has a project, they can actually create an environment YAML file for their projects, and then they can provide it to you, and they can set this YAML file to kind of be the configuration of that's basically Python environment, and explain all the version of every single packages there. And then that way you would be able to kind of get this YAML file and install an environment using miniconda that mimics their environment. So the book repository that you have downloaded earlier, it actually contains the YAML file for the book. As I mentioned, this file contains a list of all packages and dependencies required to run the code in the book. So to create an environment using this file, so basically you can navigate to the directory where the file is located, and then run the following command: conda env create -f environment YAML. So this will create a new environment with the same name as specified in the YAML file, and then install all the packages that listed in the YAML file configuration. And once the environment is set up, you can activate it by running conda activate and the name of that environment that's in the YAML file. Okay, so let's get back to the screen, the terminal. So let's just connect the dots together. What did we do so far? We download the repository either manually with going to the website, or using the Git to clone the repository. We installed miniconda. We didn't go through installation of the miniconda, but we provide you a reference that you can actually go and then install it yourself. And then we also show you how you can create an environment with the Python 3.9 version. We name it PyML, we activate it, and then we install NumPy in it. Okay, so if we want to continue this route, of building the environment one by one packages to be able to kind of execute the codes of the basically this machine learning textbook or any other projects, then I have to actually go through every environment requirement, which was, for example, stated in page 16. I did the first one, which was NumPy 1.21.2, but there's like several other packages. For example, there's one of the requirements is SciPy 1.7.0, which means then I have to go here and type conda install and then say SciPy and then be like, okay, 1.7.0. I have to install this, install the next one, and hopefully the book provided all the things properly, all the listings are right, I'm not making any mistakes, and this environment that I'm making hopefully would be correct. Okay, so that's one way to go about it, and you do need to learn it in general, because sometimes you want to make your own environment or then custom environment for other projects. So, but now let's try another way that we just discussed, and that's like using the environment YAML file. But before doing that, and this is a good exercise, remember we are still in the PyML environment that we created earlier. So let me clear the screen to go on the top of the screen so that you would see we are in the PyML environment. So as you recall, if we want to get out of this environment, we have to deactivate this environment. So we first deactivate the environment. And okay, that is good. So we are on the base. Base would be like just the base of Miniconda. So, and by the way, I recommend do not install anything on the base. Some users, when they start basically data science, they just install everything in the base, especially those that they don't have an understanding of what is this environment and virtual environment for, and they just go say, oh, okay, so I just see conda install. Don't do that. So you need to pay attention to what is in here. Otherwise, you would have a bloated base that one day you would want to run something and you would get some weird error, which you don't know why you got error. All right, so now let's go to the directory where we downloaded the book. In my case, it was this test folder. So and in your case, it might be somewhere else. So I'm in the directory of my book. So, and then let's see whether we have that file. And I've been using some basic Linux commands, so I won't go to explain those things because we're not teaching Linux. And if you know it, it's fine. If you don't, you can just use a file browser and check things. So environment YAML file is here. So that's the file we were looking for. So, and then let's use the command that we learned earlier to instruct the conda to create an environment based on this environment YAML file. And maybe it's not a bad idea so that I show you what does this YAML file look like. So this is what the YAML file looked like. So it's basically telling you which channels you would get the package from, and it already basically specifies each of the dependencies. If you look at the dependencies, they look very similar to the page 16 of your book, assuming you have the book, but you don't have to. All right, so no distraction. We're back in the terminal. Let's install the environment leveraging the environment YAML file that's provided. And the command was conda env create -env, which would be standing for file name. And yeah, the system start to kind of download and extract the packages. So, and starting to kind of basically installing the environment. And I'll let this, well, I think it's done. So perfect. So yeah, so it basically finished having an environment following the environment YAML configuration file, and you can actually activate this environment by just conda activate and naming the environments, which is in that case is machine learning book. So voila, you're done. So And you see we're in the machine learning book, basically, environment. So in case you're watching this video and you saw some error earlier, I wish I had the tools to kind of cut that off, but just to not get you confused, because I installed this prior to having this online lecture. The system was not happy with me having them basically installing the system one more time with the same name. So I just went and then removed it and then reinstalled it. Okay. Perfect. Yeah. So at this point, we want to switch gears and basically sort of teaching how to use the code on Google Colab and basically Kaggle notebook, right? So if you get lost so far, it's a good time to forget everything you heard so far and think this is a new class. Every information I provided you so far was under the assumption you want to install Python, miniconda, and take care of your package management on your local machine. This is not advised unless you're an advanced user or you have some reasons to do so, or you are just a curious person and you want to make sure you understand everything and you want to understand Python sort of virtual environment setup. You don't have to do this for this course. There are easier ways to do so. Specifically, as you move on your trajectory of machine learning, not necessarily in this course, and you're tackling more interesting problems, it is often the case you need a GPU, and you might not have GPU on your local machine. Although I do have always a GPU on my machine, and the Mac, I have Apple M1 Max Pro chip, the new chip that Apple has. And if you have this and you like to learn more about how to install sort of Apple M1 specific packages for Apple M1 Max Pro neural engines, you can send me an email and I can provide you some of the instruction that I use to install those things. And all those things, the reason I have Apple M1 Max Pro chip or a GPU on my other Linux machine is just to, it's not necessary, it's just to kind of make sure that I understand how to handle servers and things like that, and maybe sometimes run a smaller sort of like version of a bigger problem, and before I would use the cloud. But anything that requires heavy resources, you should use cloud, or you should use some facilities that's been provided to you at the university or the research team that you're working. For example, if you would be at my research team, we just purchased a big server for University of West Florida, which we are working with the IT folks to kind of set that up, and that provides GPU. That's not going to be used for this course. That's for research. For this course, we're using free resources, and I encourage you to take advantage of these free resources. And they also have free GPU. And although, again, I don't think for most of the works that we're covering till toward the end of this course, you actually do require GPU, but it is good to know that GPU for free is available with, of course, I guess, limitation hours. And this information I'm providing to you is the information on January 2023, and things are changing. The company is changing their policies. 6 months later or 12 months later, they might not offer free resources, but they do offer right now. So, and we're going to use that. So in this slide, we're going to cover how to use Google Colab for the course. So Google Colab is a free cloud-based platform that allows us to write and execute code in a Jupyter notebook environment. One of the benefits of using Colab is that it gives us access to free GPU usage, which can be useful for running machine learning models. Additionally, Colab allows for easy sharing of notebooks, which can be useful for collaboration on projects. So to get started with Colab, we will first create a new notebook by going to Google Colab website and clicking on the new notebook button. Once we have a new notebook open, we can navigate the interface, which includes menus for creating new cells, running codes, and even saving our work to get back to it later and continue. To upload the downloaded code from the GitHub repository to Colab. And by the downloaded code, I mean the code that we have already downloaded for the course to our local machine. We will use the File tab in the left sidebar to navigate to the code folder and then click on the Upload button. This will allow us to select the code files from our local machine and upload it to the Colab. So finally, we will demonstrate how to run a code in Colab by showing an example of a running code in a cell. So with that being said, let me just shift the gears and move on to the demo portion. So let's open up a Colab. So let's say I forget the Google Colab website URL. So if you search it on Google, that would be the first thing that pops out, right? collab.research.google.com. So if you are already logged in with your basically Google account, this is what you should see. As soon as you actually come, you should see basically on a screen. You probably don't have any recent projects because yours should be empty, right? But that's something like this. If you haven't logged into your Google account, you might actually be asked to log in by your Google account, and you just provide your credential, your regular Google credential, or actually your UWF. So because UWF is also hosted on Google. So you should be able to do that by UWF. Let me check what I'm actually using right now. In fact, I'm actually now using Google Colab as my under my UWF account. So, but you can use it on your personal account too. Okay. So now you're here and you want to sort of work on a new project, or you wanted to work on your homework, or you wanted to see whether you can understand the codes that's been taught in the course and upcoming lectures, and you would press new notebook. You could give this a name, so you can just name it something. I would call this Sync Session 2, Jan 18, 2023 demo. Okay, that would be the name, and then it would be stored at your Google Drive. You would press File, and you would press Upload Notebook. There would be basically a screen here that would ask you how you would like to sort of download things. In my case, this is where I stored my book that I already downloaded from the GitHub in the earlier part of the lecture. In your case, it might be on your download folder or wherever you have downloaded your machine learning book. If you have forgotten this part, pause the video, go back to the beginning of the video, and then I would actually want to kind of open a file in chapter 2, because this is going to be the chapter that we will release videos for pre-recorded videos for this soon. And I want to see whether I can actually run the code of this chapter. So a good practice is, in order not to kind of like mess up with the original code, I usually duplicate the basic, basically the codes that IPython notebook that exists and add my name into it, so that I know I have the original one, so that I don't have to go re-download if I mess up the whole thing. I have still the original access, the original IPython notebook in case I messed up something. Okay, so that's good. I actually managed to basically get the file that I downloaded from GitHub to my local machine. I managed to upload it now to the Google, and let's try to see whether we can run some of the code cells. As you see, every Jupyter notebook has code cells, and it has also sort of this markdown cells where you would basically see some instructions, or you can kind of put some explanations and things like that. So I would just click on here. You can actually click here and execute it. I don't like to use mouse, so I use Shift and Enter to execute a code, which is you can use that Shift and Enter also in actual local way of running this. And in fact, I would basically show you how to do it on the local version that you downloaded after we covered Kaggle. So this will start to kind of rotate. When it's actually rotating, that means it's trying to kind of execute. This right side shows that you've been allocated to a Google Compute Engine here. You have 1 GB of RAM. You're using 1 GB of 12 GB RAM. You have also like 30. This session has 35 gigabytes. Well, I think I have 100 gigabytes, and I'm actually using 34 gigabytes of the space as well. So this is your computes here. This cell is interesting cell. You're going to see the errors like this. I just wanted you to see one error and then see that sometimes the error doesn't matter. So if you run this cell, I just press Shift and Enter. You could actually press this. You would get an error. And the error is no module name Python environment check. Remember, the codes that's been written for this textbook are not basically suppose that you're using basically a Google Colab or Kaggle. That's something that we do. But we always test the codes and make sure the important part of the code that should be executed it's actually executable in Google Colab or Kaggle. And if there's something wrong or some issues, we will discuss. So far, the codes that we have executed, there's no problem. And again, this portion doesn't matter because, as I mentioned, you're not in charge of. You can install specific packages also in the Google Colab, but sometimes also you can't change the kernel so much. And that's why basically we taught you the other way around, where you install things locally, which you have more control on the environment. So what's basically complaining is the NumPy version is different. So we have to I'm sorry. What's basically is complaining is it's not able to actually check the NumPy version because the Python environment check function, it doesn't know that. So this environment doesn't know that, but that doesn't matter. So but this is not a crucial part of this code. Later on, I will show you that you would get errors for all these pictures. Remember, all these pictures are installed locally on your machine. They do not exist in Google Colab. So if you run any of these commands, you would get error, but we don't need them. So that's why I'm not executing them. And you should not execute them either, because once you execute, then you would lose this picture on the Google Colab, unless you're running those things locally, which I will show you later. All right, so this is a good piece of code, which you will get more explanation about this in the upcoming lecture that's being posting soon. It's about perceptron algorithm. And then once in the lecture, we will talk about the perceptron. We get to the point that then we want to kind of run the code. And in your homeworks, you might be asked that use the perceptron algorithm to do something. So that's what you should be able to do. You should be able to first execute the original code. You can press here. I don't like to press, so I would use Shift and Enter. There's a green check mark here, which means that this successfully ran. No error came after it. You see the cursor is actually jumped to the next. That means like I managed to do this successfully, and there's the green, so no error, which means that the code successfully executed. There's just a test code here. It's not an important code, but just a test code to see the angle between two vectors. And these two vectors are basically parallel, so the angle is 0. So again, you see that the code is running. And then let's try one more code. So this code, if it actually successfully ran, It's supposed to import Panda, and it's supposed to connect to UCI websites, download Iris dataset, and then basically shows the tail of that dataset. So remember, the result you're seeing here is the executed result in someone else's machine. But if I actually now run it again here, then I would be able to see what the result would be right now. So you can press here on the play. I don't like that because it doesn't make sense. So I press Shift and Enter. That's how a Jupyter is on other machines. Successfully download and gets the whole data set. So code is running here. Let's do a plotting here. You have a code that creates a plot. Remember, this is previous results that is executed from someone else's machine from the GitHub repo. But if I run this, it has to recreate this. If it gets error, I mean, something is wrong. You can run the code by pressing here. I don't like to do that. I press Shift and Enter. You see the size changed when you're actually running it in the Google. But these are an example of you can actually run this. Okay. So that's pretty much the portion on Google Colab. Let's change the screen and go back to the presentation. So moving on. So far, you've learned 2 ways to execute the code. I demo actually executing the code with one of the ways. I just showed you how to install the environment in one of the other ways, but I didn't actually run any code locally, which I will do after we finish this. But then now we're going to the third approach, which is Kaggle. If you didn't care, and if the first portion of the lecture about installing things locally was hard or cumbersome, or if it's too much details, etc., you just want a clean-cut approach to jump in and write codes, you should start using Google Colab and Kaggle. Even if you're comfortable with doing that, you should also know how to use Google Colab and Kaggle because it also provides you free GPU, which you probably don't have on your local machine. So Kaggle is a platform that provides also powerful computing resources and pre-installed packages for data science and machine learning projects. So we'll go over how to create a new notebook on Kaggle, how to upload the downloaded code, and from downloaded code that we just downloaded from the GitHub for the code. And then once the notebook is set up, we will also go over an example of running code, very similar to what we have done in the Google Colab scenario. So let's say I don't know what's the Kaggle URL. I'll just go Google Kaggle, and the first website is Kaggle. If you don't have an account, I do have an account in the Kaggle. You're going to be asked to create an account. I do already have an account, so it just pump into my Kaggle. If you don't have an account, you can just create an account, right? And looks like it gives you 34 hours of accelerator, means like 34 hours of using GPU, and I haven't used any, so I better use this free GPU for some research. So 34 hours of free GPU it's too much. In this course, you don't even need that, and you can actually go and then make a calculation how much that does this cost. I guess someone in the course mentioned that they are from Amazon, so they could actually give you a quote on how much this free resources actually costs if you actually pay for it. So it's a good resource for research. So once you're here, so you would press create, and then you press new notebook, and it creates a new notebook. The name is usually some weird names here, so I would go and make this change the name to something that I could recognize later. So that would be ML sync session, sequence section, Jan 14, 2023. And then I want to be able to upload the codes of the course that I did download earlier. So, and then I would go here and then press import notebook, and then this diagram allows me to kind of very similar to the Google Colab platform, right? So, and then I'm in my local machine here, and I would open up the chapter 2 notebook, and then I press import. There you go. You have the chapter 2 notebook here. So one thing that's interesting is here, I think by default, when you start the notebook, the system is off. So you have to go either turn it on manually, like start a session, or you have to run one of the commands, and the first command takes it for a while because it is not yet sort of assigned some actual physical resources. So let me just run the first command. So I didn't press this, feel free to press. I like the keyboard. So as you see, as soon as I press Shift and Enter on this, this started on the top drafting session, waiting for booting a kernel. So it's actually now started to, now it actually allocate hard disk and CPU and RAM on the cloud. So yeah, now the session is actually on, right? And this session is on CPU. I don't think you should use GPU. Don't use the GPU for the homeworks unless it is required, because the service is free, but why should we use something that we don't need? That unless you are actually doing something that that's kind of about image processing or video processing, audio processing. For those, of course, you should use GPU. So, but for these basic initial notebooks that we have, I think toward the end of the course, you don't need GPU. Okay, so the first thing I ran here, I don't, so I press here, again, I can here press execute. So I would run this cell and I should get some error, just to show you that the first cell, some of the cell doesn't matter if you get error, right? Because again, like I said, Python environment check is not installed in this kernel, and you don't need it for the code. And the idea is not you should be able to run everything. You should be able to run things that you actually need, right? So for example, we go back again to Perceptron, and as I explained earlier, don't run these commands. You're not going to get these photos because these are stored locally in your machine. So you get an error. You get an error because file name -figures 4 does not exist here in the cloud. You only uploaded the Python notebook there. But then when you run a proper code, like something like that, he already knows NumPy. You don't have to install NumPy. So you just import it and then, you know, Shift and Enter here, or press the play again. It jumped to the next, and anytime it jumps to the next, that means like there was no error. If there was an error, you would see an error here. So here again, and again, when you get these numbers here, like I'm getting number 5, number 4, that means that the 5th command is successfully, you know, executed. Now there's a question: what is this? Why this is 3? Because this order is the previous order of things that have been run on whatever machine that this file existed and executed. So this has not been ran here. This result is from the previous machine. Let's run this and see whether this can connect to this URL, get the data set from UCI website, and then we should get some similar table like this. Shift and Enter. There you go, it actually works. I'll execute this one as well. You're able to plot the data, execute one more. So all's good here. Okay. Let's pause here. And the next slide that we have is a wrap up of the course. But before we go to the next slide, I'd like to kind of revisit the local installation on the terminal, which we did. So we have seen how to execute the codes on Kaggle and Google, but we just install the things locally, but we never tested it. So you might actually ask yourself, why did you do all these things? So why not we actually go to the terminal where we left off, use the command Jupyter Lab or Jupyter Notebook. I like the Jupyter Lab interface. Press enter. And voila. Okay, good. So what you're seeing here is not Google Colab. It's also not Kaggle. It's just a simple Safari browser on my machine, which is running the codes locally on my machine. And this is my files. Like I have access to all of the files that I have downloaded. And since I executed a command from my machine learning book, I see the entire book here to the left. So I can go to chapter 2 and notice that this is a new book that I just basically downloaded. So it's different from the other version of the book that I had in another folder. So everything is clean here. So I can press chapter 2 IPython notebook, and I can start running the code again. Like if you like this kind of graphic things, you can actually use play, run the commands. I don't like, I like shift and enter, which automatically execute things. Let's execute the first command. If it was successful, let's execute the second command, this portion of the environment checking command, which we were getting errors in the basically Google Colab and Kaggle, and see whether we are getting error here or not. Interestingly, you won't get any error here. And why is that? Because, you know, we did install everything according to the basically YAML configuration file that's been given by the author, but nothing to worry. Those error that you would get there was because that Python environment check was not there. And I don't think you would face any error using Kaggle or Kaggle or Google, but if you know you get to that point and you had some specific errors on Kaggle or comments for future courses and future modules, then we can discuss that. But I usually try to test things and make sure it works across different platforms. Another interesting thing is, unlike the previous Kaggle and Google interface where I was telling you don't run these commands because it doesn't have the images, here actually you can run these commands. And because it's my local machine and the repository has all the images, so I can actually run this and I can get the code, or I can copy this and, you know, like copy this code, for example, and maybe create a cell below and then paste the code again here. And then, you know, for some reason, I wanted to have that picture here again, right? So everything is running perfectly here because the repo that you actually downloaded has all the pictures and everything of the course. Let's get to the same implementation code. So again, I press shift and enter here, shift and enter, shift and enter, no error. So everything is going smoothly. Let's get into this part of the code, which is supposed to connect from my machine to UCI library, UCI repository, and get the iris data sets and then show the last couple of cells. Works perfect. And this one, just see whether we can actually recreate this plot again here. Yeah, actually we recreated and make it even nicer. In my machine is kind of bigger. And here, same thing, we can execute everything. All right, so let's go to back to the slide. All right, so that's the final slide. And this session was a long session. I usually like the sessions to be shorter, but I hope it was a useful session for you and you can actually use it. In the session, we covered some key tools and techniques to help you get started with machine learning with PyTorch and scikit-learn textbook. We've shown you how to access the codes from GitHub, how to install and use mini conda on your local machine, and how to launch the codes on Google Colab and Kaggle Notebook. Remember to use the virtual environment to manage your dependencies and packages. This will make it easy to switch between different projects and ensure that you have the correct version of all the packages installed. And that's the advice if you're using this system on your machine, on your local machine, not on Kaggle and Google. I hope you find all this information useful.